video will help you review for the 7th grade Unit 5 test. You'll notice that there are two of each question. There's an unshaded number 1 and a shaded number 1. So you're going to use the video lesson to complete the unshaded questions with me. I'm going to walk you through it step by step, and on these, your paper should look just like mine. Then, when you understand how to complete the unshaded question and you have it fully done, you're going to pause the video and do the shaded question by yourself. So you'll move on to the shaded number 1, which is very, very similar to the one that we'll be doing together. Once you have worked out that problem, I need you to come and show me your paper so that I can give you a stamp for your correct work and your correct answer. And then you'll go back to your seat and unpause the video to move on to number 2. So I need you to always make sure that you're getting the shaded question stamped by me or by your teacher before you move on to the next question in the video. If there's something that is challenging to you and you don't quite understand, or you want to make sure that, that you fully understand something, you have a question, please put a star next to it. That way, when you have finished the review, you remember to go back and make sure that your teacher is able to answer those questions for you. So let's start with number 1 together. Jeremy was looking at the architect's blueprint for his house. He knows that the dimensions of his bedroom will be 18 feet by 21 feet. The scale on the blueprint of the house is 1/3 of an inch equals 1 foot. What are the blueprint dimensions of his bedroom? So we know that this is a similar figures question. We know because we're given a scale factor, 1/3 of an inch on the blueprint equals 1 foot on the real house. And so anytime we have a similar figures question, we can go ahead and draw those figures to use as a visual. So let's do that. The first thing I'm going to draw is the real bedroom. This is the bedroom. And we're told in the problem that his bedroom is 18 feet by 21 feet. So I'm going to say 18 feet, since this is the shorter side, by 21 feet. Notice that a room, or a rectangle, has two dimensions. It has a length and it has a width. So we're going to need a length and a width for our answer as well. And we'll come back to that. Here is our blueprint. And we're not given any dimensions at all for the blueprint. So that is what we have to figure out. We have to figure out the length and the width. So what is the side that corresponds to 18 feet and what is the side that corresponds to 21 feet? We're given one more piece of information in this problem. We're given the scale factor. So our scale factor, or our SF, is 1/3 of an inch equals 1 foot. Now, I know that I need to start with this as my first ratio. In fact, let's go ahead and divide the remainder of our space into 2 parts. So I'm going to say, all right, I've got 2 parts. So I'm going to use this part for the length and this part to find the width. Because I have to find 2 dimensions. I have to find the length and the width of my blueprint. So I know that I need to start by naming my ratio. We always start a proportion by naming our ratio. So my ratio is going to be named just like my scale factor. I'm going to do inches over feet. So those are the 2 units that we're comparing. I'm already given one of my ratios in the problem. 1/3 of an inch equals 1 foot. Now the problem I have here, as I go to set up my proportion, let's do line equals line. It's not a percent problem, so we're not going to put 100 down here. The problem I'm facing is that doing inches over feet would put 1/3 over 1. And I really don't want to have a fraction inside of my ratio. So what I can do is I can come up with an equivalent ratio. Instead of 1/3 of an inch, I'm going to change this to 1 inch equals some number of feet. Well, how many feet would it be? If 1/3 of an inch is 1 foot, then 1 inch would be 3 feet. So I'm just multiplying it by 3. So I'm starting with, remember this first one, this is always what we're given in the problem. This is our scale factor. That's starting with what we know. So I know 1 inch in the blueprint is going to equal 3 feet in the actual house. And I can even go over here. I think I told a couple of classes to do this. My blueprint is inches, and my actual house is feet. That way when I get to the end, I know what units to use. This is where I'm actually having to do some thinking. So we're going to do our length first. So I'm going to use 18 feet. Well, where does 18 feet go? Does it go on top or does it go on bottom? It goes on the bottom because feet goes on bottom. It's 18 feet, so that has to go on the bottom so that I'm being consistent. I'm going to put an X on top because that's what I'm looking for. So in this proportion, I'm starting with the scale factor. 1 inch equals 3 feet. So how many inches corresponds to 18 feet in the real bedroom? Basically, I'm going to be finding this side right here. That's my X. So now we know what to do. We have a lot of practice solving proportions. I'm going to cross multiply. 3 times X is 3X. And then 1 times 18 is 18. I need to get X by itself, so I'm going to divide both sides by 3. And I can cancel out those 3's. And then X equals 18 divided by 3 is 6. Now hold up just a second. I need units. And so I need to look and see, am I looking for inches or feet? Well, X is on top and inches is on top. So that reminds me that my units are inches. So now I am halfway done with my problem. I have found this side. Now I need to find this side, or the side that corresponds to 21 feet on the blueprint. So we're just going to go through the same process. Name your ratio. It's still inches over feet. Nothing is different here with the process. Then I'm going to do line equals line. I'm still starting with my scale factor. So remember, this is our scale factor. This is what we know from the problem. So 1 inch equals 3 feet. And then this time I'm looking for this side. So this time it's going to be X right there. So again, I know 21 feet. Where does that go? Well, it has to go on bottom because feet goes on bottom. So I'm comparing it to the corresponding side. And X goes here. So notice, this is exactly the same process. All we're doing is using 21 instead of 18 feet. So 3 times X is 3X. 1 times 21 is 21. I'm going to divide both sides by 3 to get X by itself. 21 divided by 3 is 7. Now I have to make sure that my units are correct, so I need to look up here. X is on top of my proportion. Inches is on the top of my proportion, and so that is my unit. So now I have found both dimensions. Remember, the question said, what are the blueprint dimensions, plural, of his bedroom? So my answer would be 6 inches by 7 inches on the blueprint. And this word by right here, this is how we say that it's one dimension and the other dimension. So this would be 18 feet by 21 feet. Here we have 6 inches by 7 inches. So now I'd like for you to pause the video and complete the shaded number 1 on your own. Make sure that you bring it to your teacher to get a stamp before you move on to number 2 on the video. And make sure that you have units on both of your dimensions. Okay, now that you have a stamp on shaded number 1, let's move on to number 2 together. Shane enlarged a painting that he had created. What is the value of x? And here is our x. So this is a similar figures problem again. All we have to do is compare these two pictures, and they are proportional. They are similar to each other. So the first thing we need to do is name our ratio. I'm going to get a color that's a little easier to see here. All right, so we're going to name our ratio. Remember, the way that I normally do it is small over big. Now, there are numerous other ways that you could do it. So I'm going to write down some other ways that you could do this. You could do big over small. You could do length over width, or you could do width over length. Any one of these will work for you as long as you're consistent. So the biggest problem that I was noticing when we were doing whiteboards before Thanksgiving was that we would name our ratio and that would be perfect, but then several students would not always follow that as they were continuing with their problem. So make sure that before you ever start solving your problem, that you look back, okay, and say, I said small over big, so that means both ratios have to be in that format before I move on. Otherwise, I know for sure that my answer will be wrong. So let's say that we're going to do small over big, since that's what we've kind of been practicing in class. The next thing I need to do is set up my proportion. So line equals line. If I'm going to do small over big, that means I'm going to start with my small figure. This is small. This is my big. So now, let's say I'm going to start with 2 5/10. That's my small. And I need to say, okay, what is the corresponding side on my big figure? And this is where it's a great idea to go ahead and write on your picture, write on your paper, and connect the ones that go together. So those two go together, and these two go together. And I would really like to see you do that on the shaded problem before you bring it to me for a stamp. So 2 5/10 over 30, that is the corresponding big side. And then over here I need small over big also, so 4 25/100 over x. Now before I start cross multiplying, I will really save myself a lot of points by going back and saying, okay, is this small over big? Small, big, yes, and they go together, they match. And this is small over big, and those are matching sides also. So check that before you go on to the next step. So 2 5/10 times x is 2 5/10 x equals 4 25/100 times 30. So that's the multiplication we need to do. Let's go over to the side. 4 25/100 times 30. Well, I know that I can just multiply by 3. So that's 15. That's 7. That's 12. And then I need 2 digits after the decimal point. And then I can move the decimal point one more time to the right and get 127 5/10. Let's go ahead and work that out completely to see how we would get the same answer. So 4 25/100 times 30. If I put all my zeros there, then I need a placeholder, either a 0 or an x. 3 times 5 is 15. 3 times 2 plus 1 is 7. 3 times 4 is 12. I add these up. I need 2 digits after the decimal point, and we get the same thing. 127 and 50 hundredths, or 5/10. So this test is going to have a lot of multiplication and division on it to help you get to the answers that you need. So don't freak out. Don't second guess yourself. You know how to do this stuff. Just remember the rules that you have already learned. So I'm going to now divide both sides by 2 and 5/10. So that I can cancel those out. And now I'm left with x equals something. So we need to do some division here. Remember, the top number always goes inside the division sign. So 127 and 5/10 divided by 2 and 5/10. But we can't divide by a decimal. Let's go one place to the right, one place to the right, and rewrite the division problem. So 1,275 divided by 25. Let's put our decimal in the quotient. And with division, it's very important that we keep everything lined up neatly. So 25 does not go into 1. It does not go into 12. How many times does it go into 127? Well, into 100 it goes 4 times. So 5 times would be 125. I have 2 left over. Bring down the 5. 25 goes into 25 1 time. 1 times 25 is 25, and no remainder. So my x is x equals 51 units. $51 units is my answer. So if you would please pause the video and go on to the shaded number 2. You're going to complete this question on your own and then bring it to your teacher for a stamp. Make sure that you have shown all of your work. Make sure that you're very careful with your multiplication and your division. And then once you have your stamp, then you can unpause the video and go on to number 3. Here's number 3. Amy and Marissa were trimming the branches of a tree. So they had to climb up ladders to get up to the branches on the tree so they could trim them. Amy was using a 21-foot ladder and Marissa was using a 10-foot ladder. Both ladders were leaning against the tree at a 30-degree angle. The bottom of the 21-foot ladder was 17.5 feet away from the tree. What is D, the distance the shorter ladder is from the tree, measured in feet and inches? Okay, that sounds really confusing, but it gets a lot less confusing when we just look at the picture. All we have here are similar triangles. So think of this as a triangle here. That's a triangle, and this is a triangle. And we're just solving for D. That's all we're doing. So I want you to ignore all the wordiness of the problem and just look at the picture. This is all we're doing. And when you get to your test, you'll have a problem just like this. And same thing, I want you to only look at the picture because they've given you all the information you need. So the first thing we need to do is name our ratio. This time I'm going to name it a little bit differently. I'm going to name it bottom over diagonal. Bottom over diagonal. So we need to start by just setting up our proportion, line equals line. And I need to be consistent. So bottom is D. And if you would like to replace this with X, you can. Since you're more familiar with seeing an X, that's perfectly fine. Now the diagonal of this side of the tree is 10 feet. So I'm going to put 10. Over here, I need bottom over diagonal also. So bottom is 17.5, and diagonal is 21 feet. Now before I start solving anything, take just a couple of seconds to make sure that you've done this correctly. Is this bottom over diagonal? Yep, bottom over diagonal, and those are matching sides. And then bottom over diagonal, okay, and those match. So I've set it up correctly. This would be the time to catch those mistakes. So D times 21, we already know that that's going to be 21D. And then 17 5/10 times 10 is just going to be 175. And let me show you how I got that. Anytime I'm multiplying a number by 10, I just move the decimal point one time to the right. Or if it's a whole number, I add a 0 because I move it to the right and I have to fill in with a 0. So I have 21D equals 175. We need to now divide both sides by what? We're dividing by 21, and those cancel out. And I'm left with just D over here. Now here I need to go ahead and do some division. So let's start with 175 divided by 21. We need a decimal, and we need to move that up to our quotient. And again, with division, we have to be very, very neat and organized. So 21 does not go into 1, and it does not go into 17. So I'm going straight into 175. So this is where I'm going to probably need some side work. Well, I'm going to start by saying 20 times 5 is 100. So I know it's going to go at least 5 times. So let's do 6. 21 times 6. That's 6, and that's 12. And I think I still have room. Let's keep trying. 21 times 7. That's 7 and 14. So that fits. Let's try 8. 21 times 8. That's 8 and 16. So that fits. Let's try 9. 21 times 9. That's 9 and 18. Okay, that does not fit. So that means 21 times 8. I'm going to put an 8 here. And I've already done the hard work, so I already know that's 168. And now I can start subtracting. Change that to a 6. Change that to a 15. And I'm left with 7. And 0 and 0. So now we need to bring down a 0 and keep going. So it's going to be 8 feet and something. 21 goes into 70. Let's try that. Let's see. Let's try 21 times 3. That's 3. And that's 6. 63. That works. Let's try 4. 21 times 4. That's 4 and 8. Okay, that does not work. So 3. 3 times 21, we already know, is 63. And I get 7 again. So I know that the 3 is just going to continue. So D equals 8 1/3 feet. But I'm not quite done yet. We're done with the hard part. But it says measured in feet and inches. So not 8 1/3, I need 8 feet and something inches. So that means that D equals 8 feet and so many inches. Well, 1/3 of a foot, that's 1/3 of 12, would be 4. So 8 feet, 4 inches. Now, even if we struggled with this part, turning this into inches, we would know that it had to be 8 feet and something. So at least we would be able to cancel out some answer choices if they didn't all start with 8 feet. So this will be 8 feet, 4 inches. Okay. So let's go back over how we did this. We named our ratio, bottom over diagonal. Then we set up our proportion, bottom over diagonal equals bottom over diagonal. And then we just solved like we would any other proportion. And you guys are so familiar and so good at proportions that if you get it set up correctly, I know you'll be able to solve it correctly. So please pause the video now and complete number 3, the shaded question, on your own. Then bring it to your teacher for a stamp before you go on to number 4. Number 4 says, to prepare for a vacation, some senior citizens use pieces of string to measure roads on a map. They used a map scale to determine the distance between 2 cities. So the map scale is just a scale factor. One group of senior citizens measured the distance between Fort Worth and Dallas on a Texas state map. The string distance was 3.75 inches, which represents a real-life distance of about 60 miles. So 3 3/4 of an inch corresponds to 60 miles in real life. Another group of senior citizens measured the distance between San Antonio and Houston and found the distance to be 8 1/4 inch. So I'm going to do circles on this one. What is the real life distance to the nearest mile between San Antonio and Houston? So this is just another similar figures problem. It's just worded a different way. So there are so many ways that we can use proportions to find a missing part of a similar figure. So the first thing we always need to do is name our ratio. Well, the 2 units that I have in the problem are inches and miles. So that seems like the best way to name it. Inches over miles. So I have done the first part. I've named my ratio. Now I need to set up my proportion. Line equals line. And we need to make sure that we have corresponding sides together. So 3 7/75 of an inch corresponds to 60 miles. Well, which one goes on top? Let's look back at how we named it. Inches has to be on top because that's what I started with. So 3 7/75 inches over 60 miles. And those two go together. And then we have 8 1/4 of an inch. That has to go on top. Over, we don't know how many miles because that's what the question's asking us. What is the real life distance in miles between San Antonio and Houston? Now before I continue, I'm going to double check and make sure I've set this up correctly. If I'm said that I'm going to do inches over miles, I have to make sure that both ratios follow that system. Inches over miles, yep. Inches over miles. Yes. Okay, so now we cross multiply. And I get 3.75x equals I need to multiply this one out. So 8 25/100 times 60. That's 0, 0, 0. Let's put a placeholder there. 6 times 5 is 30. 6 times 2 is 12, plus 3 is 15. 6 times 8 is 48, plus 1 is 49. So we get 0, 0, 5, 9, 4. I need 2 digits to go after the decimal point. So this is 495 even. I don't really need the 0.00 there. Now I'm going to divide both sides by 3 75/100. These cancel out, but bummer, now I have to divide by a decimal, so that's okay. We just have to be very neat with this. So 495 divided by 3 75/100. That means I need to move my decimal point 2 places to the right. So I'm going to do the same thing here. Fill those in with zeros. And then rewrite our problem. So 375 out here. And then 49,500 here. And let's put our decimal up in the quotient so that we don't forget to do that later. Now, 375 does not go into 4 or 49, but it goes one time into 495. So we can start multiplying here. That's 375. I get 0, 2, and 1. Let's bring down one of these zeros. 375 into 1200. Well, this is where I start practicing. So 375 times 2, that's 10, 15, and 7. Okay, let's try 3. 375 times 3, that's 15, 22, and that's 9, 10, 11. And that's pretty close to 1200. I don't think it's going to go a fourth time. So let's put 3 right here. I already know 3 times this number is 1,125. And I can start subtracting. This becomes a 9 and this becomes a 10. I could have made this a 10, but then I would have had to borrow from it. So I was just skipping a step. That's 5 and 7. All right, we still have one more zero that we have to use. So 375, oops, I already know that 375 times 2 is exactly 750. What luck. Okay, so 2 times that is 750. And we are all done. So my answer would be x equals 132. Oop, what's my unit? X is on bottom and miles is on bottom. So that's my reminder that my unit has to be miles. So now I'd like for you to pause the video and go on to the shaded number 4 on your own. I'm going to cross this out because, to be honest, when I wrote this review, I was thinking something else when I put that in there. So we're going to cross out the part about drawing a picture for both trips. All you need here is to name your ratio, set it up, and solve. So the hardest part about this, or the longest part about most of these problems, is actually doing the multiplication and the division. So you guys are going to get really good at that as we review and take this test. So please pause the video now. Number 5. The ratio of width to length of the Texas flag is 15 to 23, as shown in the scale drawing below. If the width of the flag in Cody's front yard is 22.5 feet, what is its length in feet? So that means that we are comparing width and length. Those are the two things we're comparing in this problem. So that's how I'm going to name my ratio, width over length. So what this problem is saying is that the Texas flag is always going to be something in this ratio. So that means it could be a really little Texas flag that you stick on top of a cupcake, or it could be a huge one that you see at car dealerships. It doesn't matter, it's always going to be in the same ratio. The one that Cody has in his front yard has a width of 22.5 feet, so we have to find its length. So let's set up our proportion, line equals line. And I'm going to start with what I know. I know that this is the relationship. The ratio of width to length, so that means 15 is our width, 23 is our length because we have to go in order, width, length. So I'm going to start with my width as 15 and my length as 23. Now, we're told that the width of Cody's flag is 22.5 feet. So that means width is on top, 22.5 feet, and I'm looking for its length. What is its length? And that's X. So all we've had to do is take what we know, width over length, and figure out what we're looking for. Width over length is, we don't know. We don't know what the length is. Let's find it. 15 times X is 15X. 22.5 times 23, we're going to need to multiply that out. So 22.5 times 23, that's 15. You can multiply this with me, please. 6, 7, and that's 6. I'm going to get rid of that 1 that I carried, put a placeholder here. 2 times 5 is 10, carry a 1 again. 2 times 2 is 4, plus 1 is 5, and 2 times 2 is 4. I add these up, 11, 5, and 1 digit needs to go after the decimal point. So 517 and 5/10. So now I'm dividing both sides by 15. Notice that every one of these problems we've been doing has been the same process. Name your ratio, set up the proportion, and solve. And every one is going to require you to do some multiplication, and then it's going to require you to do some division. So just get in that habit, and you know the process. Trust yourself. So 517 and 5/10 divided by 15. I do not have to move my decimal point because I'm dividing by a whole number. Let's move our decimal up to the quotient. And it's time to start dividing. So 15 does not go into 5, but it does go into 51. So I know 15, 30, 45, and then 60. So it only goes 3 times. And you can always do this off to the side if you need to. 3 times 15 is 45. This becomes 11, and this becomes 4. So 11 minus 5 is 6. Let's bring down our 7. 15 goes into 67 4 times. I know 4 times 15. Well, 2 times 15 is 30, so 4 times 15 is 60. And I get 7. And then I bring down my 5. 5 goes into 75. Well, 60 plus 15 is 75, so that means it would go 5 times instead of 4. And that's 75. So we are done. So over here, we get X equals 34 and 5/10 feet. Now, I want to talk to you about how we fill in these bubbles, because unfortunately, a lot of kids get the right answer here, but because they don't bubble it in correctly, it is actually counted wrong. So let's talk about how we bubble it. First, we need to decide if it's positive or negative. Well, it's positive in this case, so bubble your positive and put a plus there. And then this decimal point has to line up with this decimal point. So that means it has to be 3 here and 4 here, and then the 5 right after that. And then we have to bubble in the numbers, and you need to bubble them in as dark and fully as you possibly can. We don't want to leave any white space, and we want to stay inside the lines. And then you do not need to bubble any other zeros. You can if you want to, but I usually find it's better just to do these. And there you have it. So please go on to the shaded number 5 on your own. Make sure that you have named your ratio, set up your proportion, and solved. And then that you have bubbled in your answers completely so that I can check that. Please pause the video now and work on number 5. For number 6, you're going to need 4 different colored markers. So if you don't have 4 different colored markers or highlighters or colored pencils or something in front of you, please pause the video and go get those 4 different colors. Okay, so now that you have your 4 colors, I'd like for us to color code these 2 shapes. So it says quadrilateral ABCD and quadrilateral EFGH are similar. So which proportion is true? Basically, which proportion has it set up correctly? Now remember, there are a lot of different ways that we can set up proportions correctly, especially since we have so many, like all of this information is given to us. So we have our choice of which sides we want to use. We have our choice of how we want to name our ratio and set it up. And so 3 of these are going to be wrong and 1 is going to be right. So we're going to test every single one of them. So the first thing we want to do is get our 4 colors and color code. So we have AB, let's just go in order, and AB has to correspond with EF. So those 2 go together. Your markers are going to be thicker than mine, so it should be easier for you. AB and EF go together because AB come first, EF comes first. All right, now get another color. BC, I'm doing this one with purple, has to go with FG. All right, now another color. CD has to go with GH. And notice, as we're doing this, like this side is across from this side. And this side is longer than this side. So it kind of makes sense what we're doing. But we're going based just on the letters right now. And then DA, that's the last letter and the first letter, has to go with HE. That's the last letter and the first letter. So these are the corresponding sides. Now, so as I've done that, I'm going to go through and I'm going to circle these just to kind of make it stand out to me even more, since all of my proportions here have used the numbers. I want to really see the numbers and how they fit together. So 5 and 7.5 go together, and 4.4 and 6.6 go together. So all of those go together. So now that we have that done, we just have to see which one of these sample proportions actually works. So I have 7.5 over 3. Well, 7.5 and 3, so that means that the other side of my proportion has to be purple over green also. So 5, that's purple, over 4.4. Well, that's purple over blue. I can't do purple over green and then purple over blue. That does not work. We have to get rid of that one. So bye-bye. Let's look at the next one. 7.5 over 5. So that's big purple over little purple. So big over small. And then 6.6 over 4. That's big blue over little blue. So that's big over small also. So this one may be right. Okay. Let's check the others. We never just pick an answer and move on without checking everything. 6.2 over 2. That would be orange over green. 9.3 over 3. That's orange. Orange over green. Okay, so we have orange over green and orange over green. So that's a maybe. And then here, 6.6 over 7.5, so blue over purple. And then here we have 6.2, orange over blue. Well, we cannot have blue over purple equal to orange over blue. That's not consistent. It has to be the same on both sides. So that one's gone. So let's look back at B and C. So here we have 7.5, big purple, over 5, little purple. 6.6, big blue, over 4.4, little blue. So that one works. Here we have 6.2, orange, over 2, green, orange over green. And then this is also orange over green. So this one works. So I actually messed up when I did this, and I've made 2 correct answers on this one. Oops. So those are both correct. Now, on the shaded number 6, I have already double checked to make sure there is only one right answer. So don't worry about that one. And on your test, there's only one right answer. So this was a boo-boo on my part, and I'm glad that we caught that together. So please pause the video now. On number 6, I'd like for you to color code, just like we did up here. And then you will also have markers available to you on your test tomorrow. And I want to see you color coding on your test tomorrow as well. I want to be able to see that on the questions like this that have 2 similar shapes for you to match up. So please pause the video now for number 6. Number 7, Chris painted a small rectangular drawing. He then made a scale drawing of his original painting to create a similar rectangular poster. Okay, so I'm going to go ahead and label this drawing and poster. He used the scale factor of 5 over 3 to create the rectangular poster. So the scale factor equals 5 over 3. If the perimeter of the larger rectangle is 45 inches, okay, so we're going to write down all of this. So P equals 45 inches. What is the perimeter of the smaller rectangle? P equals blank. Okay, now we remember from that activity that we did how scale factor affects area and perimeter. We kind of folded it into thirds and glued it into our journal like that. And we came up with a rule. We came up with a rule of if we do something, if we enlarge or reduce a figure by a particular scale factor, we came up with a rule for what that does to the perimeter and another rule for what that does to the area. So in this case, we need to know about the perimeter. So what we did to this, to get this, is we multiplied it by 5/3. So remember, that's all that's happening to the perimeter. We multiplied the perimeter by the scale factor. So something times 5/3 is 45 inches. Now, I can go ahead and get rid of some answers because the perimeter of the larger poster is 45 inches. So that means the drawing, the original small drawing, has to be smaller than that. So I can get rid of 75 inches, and that's the only one I can get rid of. So keep in mind that I'm multiplying a number times 5/3 to get 45. So let's test each one of these. Let's test 27 times 5. Well, 27 times 5 is, let's do 27 times 5. That's 35. And that's 13, 135. And then divided by 3. So times 5 divided by 3. 135 divided by 3 is, let's see, 135 divided by 3 doesn't fit. 4 times 3 is 12. 15 here, and 5. So 5 times 3 is 15. So we get 45. So this one probably works. Let's test the others. Let's say 3 times 5, that's 15, and then divide by 3 equals 5. So that's not it, because then if the perimeter here was 3, then the perimeter here would be 5. So that does not work. And then let's do one more. 18 and 5/10 times 3. Let's see, 18 and 5/10 times 3. That's 15, 24, 25. 3, 4, 5. So 555, I need one digit after the decimal point. So that's 55 and 5/10. And then if I divide that by 3, I'm not going to get 45. I'm going to get something smaller than that. So that doesn't work either. So all we have to do on this problem is first realize that the larger rectangle is 45 inches. So I'm actually trying to find the smaller one, not the larger one. So I just need to see which one of these can I multiply times 5 and divide by 3 to get 45. So you're going to do the same thing down here. It's still going to give you the perimeter of the larger rectangle. You're still going to be looking for the small one. And you're going to say, which one of these perimeters can I multiply times 7 and divide by 2 to get this perimeter? That's all we're doing on that one. So please pause the video and move on to number 7 and then come get it stamped. Okay, number 8 is very similar to number 6. So we're going to get those colored markers out again. This time we only need 3 of them. So I'm going to be coloring the similar or the corresponding sides. So triangle ABC and triangle DEF are similar. So which proportion must be true? And we're going to color code this. So I'm going to start with AB. I'm just going to go alphabetically. AB has to be the same as DE. Notice that's the longer side on both of these. Then I have BC, which is the shortest side, has to go with EF. And then CA goes with FD. So now that I have color coded those, I can easily see what goes together. And I'm actually going to color code my answer choices here too. So FD, that's orange, over AB, that's green. Okay, so already I'm doing orange over green, and they're on different shapes, so I really can't do that. And then, but let's just kind of play this out and see what happens. So FE, that's blue, over AC, which is orange. So this is completely messed up. That is not going to work. So I'm going to get rid of A. All right, let's look at B. FE, whatever color you did that, go ahead and circle it, over FD, and then CB over CA. Okay, so this one might work. For me, it was blue over orange, blue over orange. Whatever your colors were, it should match up. So we're going to leave that one for now and come back to it. Okay, here we have BC over CA equals EF over DF. All right, well, hold on. We're going to have to come back to that one too. And then let's look at this one, FD over CA. So orange over orange for me. And then AB over DE. All right, so I have 3 right now that I'm looking at. Let's start with this one. FD over CA, so that's this one over this one. But then I have this one over this one. So I can't do the right triangle over the left triangle and then left over right, because that's not consistent. So I need to get rid of those. Okay, so now I have B and C. I'm looking here, FE, that's this, over FD. So FE, FD, which means that this would have to be CB, CA. So it works. Check. Here I have BC over CA. So I'm going in a consistent line, BC, CA, and then EF, and then it should be FD, but I have DF. So I'm going to get rid of this one simply because of this. This, if it's EF, it should be FD instead of DF. So I am going to go with B as my answer. It is consistent. Again, on your test, I would like to see that you're color coding your shapes, making sure that you're going alphabetically, A, B, C, D, E, F. So now please do number 8, the shaded question, on your own. Make sure it's color coded, and make sure that you're showing me, when you bring me your paper, which one of these proportions is set up correctly and must be true. Please pause the video now. Number 9 is another scale factor problem. Elijah was visiting the art museum. There was a map on the front of the brochure. The legend on the map, or the key on the map, stated that 4.5 centimeters represents 7.5 feet. So that's my scale factor right there. My scale factor is 4.5 centimeters equals 7.5 feet. How many centimeters would represent 7 feet? Okay, so 4.5 centimeters and 7.5 feet, those go together. And then it says how many centimeters would represent 7 feet, and those go together. So this is my X, how many centimeters. So we're going to start by naming our ratio. And again, we have a scale factor, centimeters and feet, so I'm going to name it centimeters over feet. And then we will just set up our proportion, line equals line. We start with what we know, 4.5 centimeters. Centimeters goes on top. And it goes with 7.5 feet, and feet goes on bottom. Now, how many centimeters? That's our X, and centimeters goes on top. And how many centimeters would represent 7 feet? 7 goes on bottom because it is feet. So again, same process over and over and over through this whole test. Name your ratio, set up a proportion, double check it, and then solve. So let's double check. Is this centimeters? Yep. Over feet, and that's centimeters. How many centimeters over 7 feet? So we are good. Let's start cross multiplying. 7.5 times X is 7.5 X equals 4.5 times 7. Let's multiply that out. 4.5 times 7. That's 35. 7 times 4 is 28. Plus 3 is 31. And I need one digit after the decimal point. So 7.5x equals 31 1/2. Now we divide both sides by 7.5. Again, it's the same stuff. You guys already know how to multiply and divide. This is no big deal. So x equals, I need to go ahead and divide. Now I know that I'm dividing by a decimal. We can't divide by 7.5, so I'm going to move that to the right to make 75. Let's move that to the right also. So I just saved myself a step here. So now we have 315 divided by 75. Let's put our decimal up in the quotient and start dividing. 75 does not go into 3. It also does not go into 31, so let's start practicing. 75 times 2, that's 10, and that's 15, so 150. Well, I know 150 times 2 is 300, so let's try 75 times 4. 75 times 4, that's 20. 4 times 7 is 28. 30, so 300. And I know it's not going to go again because that would be 375. So we're going to put a 4 here. 4 times 75 is 300. When we subtract, we get 15. So we have to put a 0 and bring it down and keep dividing past that decimal point. I already know that 75 times 2 is 150, and I get a 0. Now here's where it's very, very important that we have our decimal point in the right place, because here we don't have any answer choices. So if you'd gotten 42, you did all this work correctly, but just that decimal point being wrong is going to get you the wrong answer. So having that up here at the very beginning and being very neat with our division is going to help us get the answer right. So remember, this is going to be 4 and 2/10, and it's what? How many centimeters? So centimeters. And then we need to bubble it. So it's positive. We know it's positive. And then 4.2 has to go exactly right here. This is the decimal point, and it cannot move. So bubble in your 4 and bubble in your 2. I'd like you to go on to the shaded number 9 and then bring it to me to get a stamp. So please pause the video now. Number 10 says, draw a pair of similar figures, label the vertices of each figure correctly, and be sure to include side lengths and angle measurements that will prove that the figures are similar. So there's several things we need to do here. We're going to draw 2 figures that are similar. So I'm going to do a trapezoid. And I'm going to do a smaller trapezoid that is similar. Okay, so I'm going to label the vertices first. So let's say that I'm calling this A, B, C, D. Then I would call this W, X, Y, Z. So we have to make sure that we're going in the same direction. A, B, C, D, W, X, Y, Z. Now if this were rotated somehow, I would still have to have this vertex be W, because this vertex and this vertex go together. And then we need side lengths and angle measurements. So side lengths, I'm going to make this, let's say that this is 1, 2, 5, and 7. Okay. And then let's say that it's a scale factor of 2 to get over here. So 1 times 2 is 2, 5 times 2 is 10, 7 times 2 is 14, and 2 times 2 is 4. So those are my side lengths. So the sides are proportional. All right, now let's go on to the angle measurements. We're going to say that this is 90 degrees, and this is 90 degrees, and then this is 120 degrees, and so to make it 360 degrees, this would have to be 60 degrees. Now, the angles of similar figures are congruent, which means equal. And we know this. This is in our definition of similar figures that we did like 2 or 3 weeks ago. The sides are always proportional, the angles are always congruent. So that means that this one has to be 90 degrees, this has to be 90 degrees, this has to be 120 degrees, and this is 60 degrees. So they have to be congruent in the angles, similar or proportional on the sides. So now I have given you, on number 10, a couple of similar quadrilaterals, and I need you to pick which one of these is correct, and there's only one that's correct. So once you have chosen the correct answer, please bring it to your teacher for a stamp, and please pause the video now.